Our last topic of Unit 2 deals with slope and similar triangles. Okay, so the one thing we need to remember is the slope-intercept form, y equals mx plus b. Remember, m is slope, b is y-intercept. And then the last thing we need to talk about, okay, what are similar triangles? We know what triangles are, but what does the word similar mean? Similar just means it's like a scale drawing of one another. So it's the exact same shape, we just have a different size. Okay, so later on when we start talking a little bit about geometry, we'll talk about congruent shapes. So congruent means same shape and same size, but similar means same shape, different size. Okay, so the corresponding sides will be proportional and the angles will have the same measure. So the corresponding angles will have equal measures. So there's about 4 or 5 things we're going to do with this, and we'll look at examples. The first example says, just focusing on y equals mx plus b, what is the equation of the line that passes through the points 0, 3, and 3, 9? Well, I know my equation needs to be y equals mx plus b. So I need to find m, and I need to find b. Well, one thing we should always check before we start is if they give us an x-coordinate of 0. Because if they do, what have they given us? They've given us b. Because 0, comma, a number, that's our y-intercept. So I can go ahead and say that b equals 3. Okay, so I've got y equals mx plus 3. Now all I have to do is find m. Well, if they give me 2 points, I want to do m equals y2 minus y1 over x2 minus x1. Okay, so I could say x1, y1, x2, y2. Okay, so I've got m equals 9 minus 3 and 3 minus 0. 9 minus 3 is 6. 3 minus 0 is 3. 6 divided by 3 is 2. So I take this, plug it in right there. So my equation of the line that goes through those 2 points would be y equals 2x plus 3. Okay, next example we're going to look at actually has 2 similar triangles on there. And if we look here, we've got a larger triangle that is AFD, and we got a smaller triangle that is BCE, or BEC, however we want to look at it. And they ask us some questions here. Part A says triangle ADF is similar to triangle BCE. That means the angles are exactly the same, and the side lengths are proportional. The corresponding side lengths are proportional. So it says between which pairs of points is the slope the same? So we just need to look at these points and see if the slope's the same. Okay, so it says A and F, so it's right here, A to F, and C and E. C and E. Okay, well, A to F, that slope is 0, right? C and E, that is undefined. Okay, so we would say between which pairs of points is the slope the same? Well, it's not those. Okay, so let's just write no next to that. So if it's the same, we'll write yes. Okay, so back here, A and F and B and E. Okay, they're both horizontal lines, so we would say yes, the slope is the same. The slope would be 0. A and D, and B and C. So A, D, B, C. Yes, they're on the same line. B and C, so B, C, and C, D. Okay, on the same line. B to C, C to D. Still the same slope, so we'd say yes. B and E, B to E, horizontal line. C and D. Oh, sorry. B and E and D and F. So B to E, D to F. No. Okay, because B and E is horizontal, that'd be 0 slope. D and F is vertical, that's undefined, so that's not the same. A and B, A and B, and B and C. B and C. Yes. On the same line. Okay. Part B to this says the slope of AD is the same as the slope of BC. All they're doing is telling us that these 2 triangles share that side. Okay, so the slope is the same. Write the name of a segment in each box of the proportion to show this. Okay, so we're going to add something here and something there, proportion. Okay. Well, if we look here, it says DF. So DF is right here. So would that be like our rise or our run? Right, that'd be rise because it's up and down. B and E is not rise, it's run. Okay, but B and E is the run of our small triangle. So we need the rise of our small triangle, and that would be C and E. So we'd write C, E right there. And since we have DF over here, that's the rise of our large triangle. So we need the run of our large triangle, so A to F. Okay, so this says that df over af, rise over run, of our large triangle is equal to CE, rise, over BE, run of our small triangle. And that makes sense because it told us that the slope is the same. And since we're finding using rise over run, that's what we're doing is finding the slope. So that's what we do. DF over AF equals CE over BE. All right, our next one says, Jimmy correctly wrote the equation of a line through the point A as y equals mx plus 4. What is the value of m in Jimmy's equation? Okay. Well, m, what are we looking for? We're looking for slope. Well, they only have 1 point there. So we need 2 points to find slope, right? Well, if I look at my equation, it says y equals mx plus 4. So 4 is b, right? That's my y-intercept. So I know this is my y-axis, so I could put a point on 4, and that's going to be my second point. 1, 2, 3, 4. So there's my other point. Now I just use rise over run to find the slope between these 2 points. So if I wanted to, I could take my ruler and connect these points, make a line. I don't really have to, since I just need 2 points to find rise over run. So if I look here, this point would be kind of like -3, 1. So if I start here, I'm going to go up 1, 2, 3, and I went right 1, 2, 3. So my slope would be 3 over 3, right? So let's do that again. So use pen here. So we go up 1, 2, 3, and we go right 1, 2, 3. Okay, 1, 2, 3. So we get 3 over 3, so m equals 1. So what's the value of m? It is 1. So we used our y-intercept there to give us our second point, and then we just used rise over run to find slope. And our last example. Okay, so remember we've talked about this a little bit before. We said that for a line or a graph or a function to be linear, then the slope has to be the same between all the points that you choose. Any of the points that you choose, the slope has to be the same. So this says the table shows values for points on the graph of a function. Can this function be represented by a straight line? And here's our coordinates, 1, 1, 2, 4, 3, 9, and 4, 16. Okay, so let's look here and let's find the slope between the first 2 points. Okay, so 1, 1, and 2, 4. So this is 1, 1, 2, 4, this is 3, 9, and this is 4, 16. So what we're going to need to do here is find the slope between 2 or 3 points just to check to make sure it's the same. Okay, so let's use these first 2 points. So we're going to do x1, y1, x2, y2. So 4 minus 1 over 2 minus 1. Okay, well I get 4 minus 1 is 3, 2 minus 1 is 1. So between these 2 points right here, our slope is 3. Okay, all right, so now let's do it between these 2 points. Okay, so we've got 9 minus 4 over 3 minus 2. Well, 9 minus 4 is 5, 3 minus 2 is 1. So between these 2 points, my slope is 5. So I don't even have to do anything else because I know that since this slope was 3 and this one's 5, the answer is no. This might be a function, but it is not linear because our slope has to be the same between all the points. So if I want to check this one, okay, let's do 16 minus 9 over 4 minus 3. 16 minus 9 gives me 7, 4 minus 3 gives me 1. So the slope between those 2 points would be 7. Okay, so since that's a 3, that's a 5, that's a 7. This might be a function, but it is not a linear function because for a function to be linear, the slope has to be the same between all the points.